Welcome back. This is lesson 6 on quantitative aspects, and we are going to do some concentration calculations. The first example is to calculate the concentration of 1 liter of table salt solution that contains 20 grams of sodium chloride. So, concentration is mass over molar mass times volume is the equation that I would use, or you could calculate the moles using mass over molar mass and then calculate concentration using moles over volume. Now here it is important to know that 1 liter of solution is the same as 1 cubic decimeter of a solution. So the mass of sodium chloride is 20 grams. The molar mass of sodium chloride, and this is where it is important to be able to write formulas, is 23 plus 35.5, so that is 58.5 grams per mole. So it's 20 divided by 58.5 times the volume is 1. So 20 divided by 58.5 is 0.34 mole per cubic decimeter. Next example, how much sodium chloride will be needed to prepare a 500 cubic centimeter of a standard solution with a concentration of 0.01 mole per cubic decimeter. So we know the concentration, we don't know the moles, we know the volume. The problem here is that volume is in cubic centimeters and it must be in cubic decimeters. So you need to divide that by 1,000 to get to cubic decimeters. Sorry, cubic decimeters. So we can calculate 0.01 is the concentration. You can calculate the moles. 0.5 is the volume. So the mole is 0.5 times 0.01, which is 0.005 mole. Now, how much would most probably mean what is the mass? So mole is mass over molar mass. So the 0.005 is mass over 58.5. That gives us a mass of 0.2925 grams, or you could say it's 0.293 grams. Next is calculate the mass of sugar that must be dissolved to make a 500 cubic centimeter solution of concentration 0.1. So I'm going to use this equation because it would give me mass. So the concentration is 0.1. The mass is what I don't know. The molar mass of sugar I need to calculate. So it's 12 times 12 plus 22 for hydrogen plus 11 times 16. So it's 12 squared plus 22 plus 11 times 16. That gives us a 342 grams per mole. So this is 342. Then 500 cubic centimeters is 0.5 cubic decimeters. The mass would then be 17.1 grams. Next, I want to show you how to calculate the concentration if you dilute a solution. I prefer using diagrams. So we have a 250 cubic centimeter solution of sodium hydroxide. In a volumetric flask, the concentration is 0.2 mole per cubic decimeter. From this solution, we take out 25 cubic centimeters. And we place it in a second volumetric flask. That's got a volume of 100 cubic centimeters. So that goes in there. Now, to calculate concentration, I need mole and volume. So how many moles of the solution, the original solution, did we place into the second volumetric flask? So to calculate moles, we need to take the concentration 0.2 and multiply it by the volume. 25 cubic centimeters is 0.025 cubic decimeters. So this brings us to 0.005, I think. Let me just check. 0.2 times 0.2025, 0.005 moles. So that is the mole in the second container. So 0.005, and the volume 100 cubic centimeters is 0.1 cubic decimeters. So this brings us to 0.05 mole per cubic decimeter. There is another way to do this. Because the mole that we take out here, we can calculate that using concentration, original concentration, and the volume that we're removing. Okay, so this is what we're removing. And we're placing it into the 100 cubic centimeters. So these moles here is the same as the moles that we're taking out, but now the concentration is different and the volume is different. So because C1V1 is N1 and C2V2 is N1, we can say C2V2 equals C1V1. So C2 times, and we've got a volume. Now, because we've got volume on both sides of the equation, I don't have to use cubic decimeters. I can use cubic centimeters because I've already got concentration on both sides. The original concentration was 0.2 and the volume that we removed was 0.025. And if you do your mathematics here, you'll see that the concentration of the diluted solution is 0.05 mole per cubic decimeter. I hope you found this useful. See you on the other side of these videos.